Okay, today's task is 1971. I'll remove the solution. I solved it long time ago, like not very long time ago, April 21st, actually. So find the graph if in a path if it exists. Okay, so that's a pretty standard task. I need to just go through through the graph defined as edges, and then from source to destination. So step number one, gonna be create uh, create a graph. Step number two, do DFS or BFS for search from source to destination. I would like to do DFS here and for this problem. So I'll do DFS. Um, yeah. So for the first, I'm gonna go through the edges and I'm gonna create a graph. Um, so graph here we have source and destination and cells. So I'll store just hash set integer, and it's gonna be graph new hash set, and then n vertices, and then if g.get e0 equals null, I just do g.put e.e0, and then new hash set, and then g.get e0.put, or maybe add e1, and do the same for the e1 if I have an age. So it's what description, let's see description. So it's bidirectional graph. So do this edge add one, and then I'll go it's private void DFS, like boolean, say boolean DFS, and then I'm gonna have int vertex, and then boolean visited, and then graph hash set g. Yeah, and that's it. And then g.get v for the neighbors, hash set integer next, like next next. So next, and for integer, let's say int next v. In next, I'll do if visited next v equals false. If not visited, I'll do the following. I'll mark it as visited, next v equals true, and then go DFS next v, then visited, then graph. That's it. And then say if v equals destination, then return true, and then boolean result equals if res equal true, then return true. Otherwise, if you went through the all neighbors and didn't find the did DFS from the all neighbors and didn't find the destination, I'm gonna return false. That's it. So I need also to pass int destination, and I need to go start with DFS. Return DFS v, or like source, then destination. Then I'm gonna go to the visit new boolean n, and then graph, and then that's gonna be it. And also I need to do this boolean visited equals new boolean n, and then I'll go visited source equals true, and then I'll pass this visited array to the DFS. Yeah, let me take an overview of the solution. So hash set, and for the n elements, for the neighbors, I'm gonna save the graph that way. Visited, okay, destination, visited, okay. Sounds like this. Private boolean DFS. Wait a second. But so this graph, what we have here, g dot put g, cannot find the symbol, hash set g got. Okay, so I need to just go, because this is going to be the array, so I need to go just g dot, instead of get, just need to access the array, g dot age equals new hash set, then Okay. No. And also not all if next equals false, return false. Oh, equals null. Mm, okay, int. Here we need TFS. This T. Okay, let's run it again. So this is BFS union union again with ranks. Then you DFS union 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 BFS this union Q Q. Okay, this is BFS also. Seems like okay, DFS here. Um, what is more efficient? With hash set. Okay, it's both BFS. And this one was DFS. Okay. Okay, whatever. I'm gonna wrap up right now. Hope you learned that. So I was doing DFS here. Pretty standard task. First, I create the graph, then created visited array and then run DFS, and then if I gonna see the destination vertex, one of the like two visit nodes, I'll or like one of the like vertices where the DFS was called. If the vertex for that DFS called, if that vertex for which DFS is called is equal to the destination, means that we found the way from the source to destination. Yep, that's it. I'm gonna wrap up. The status is pass. Yeah, that's it.